The history of the world can be written in terms of war. Many a conquering hero has been hailed. Many a victor has enjoyed many a spoil. Tacticians learned quite early that for every measure, there must be a countermeasure. Elements of strategic warfare: attack countered with sneak attack, countered with strategic withdrawal, but man soon learned the advantages of fighting effectively at a distance, and the space between adversaries became greater. The measures of war became more effective, more accurate, more deadly. As civilization progressed, so did man's ability to wage war. It soon became apparent that in a constantly shrinking world, a warning system would become an absolute necessity. Less than 20 years ago, the warning was inadequate. But there was a defense, the natural defense of distance and time. Time to marshal the greatest military force the world had ever known. And time to use it. Now, this natural defense is greatly reduced, and we're living with a new threat. The defensive value of distance and time, as measured in terms of 15 years ago, no longer exists. Our radar network must provide us with complete coverage. Our wall of protection must be as near perfect as possible. We must have the earliest warning, continuous surveillance, and a more than adequate defense. We must be able to pick up attacking forces, track them, and commit our interceptors against them in time to move the nuclear war out to unpopulated and overwater areas. This we can do under ideal conditions. But what happens at the radar site when the scope turns white? What happens when electronic countermeasures are employed? When the enemy utilizes all of his electronic know-how to render all of our electronic know-how ineffective? Specifically, his purpose is to prevent data reliability. And he does this with frightening efficiency. If our radar plotters could detect individual enemy aircraft within the ECM environment, there'd be no problem. But no reliable system is available at present, and the problem does exist. The absence of such fine-grained data in this situation leaves the alternative of utilizing whatever information is available. Operation MANTRAC, manual angle tracking capability, is designed to use angle-only data. MANTRAC grew out of a desire to verify war games analysis, assumptions, and rules. War games were set up to be run in real time on paper. The system was good. It produced a thorough familiarity with all phases of triangulation. But on paper, it was cumbersome and slow. This led to a search for faster methods of wargaming. And after a succession of experimental plotting boards, the present MANTRAC triangulation system evolved. A passive receiver designed to present the directional antenna modulation was installed to provide strobe data. To the antenna of the search radar, a field strength receiver is attached. The jamming signal received by the antenna is measured by the field strength receiver and displayed on the planned position indicator. This enables display of angle data, and in effect, the scope becomes a strobe indicator. Estimated readout accuracy, 1/2 degree, and can resolve 2 or more aircraft at approximately 1 degree. Under normal procedures, 2 men can modify a radar sight in 4 hours. Once the sight is equipped, the data presented on the strobe indicator is reported to the MANTRAC triangulation board. As an example, let's assume that 2 sights initiate a track on 1 jamming aircraft. The point of strobe line intersection, determined at a given time, fixes the aircraft position. As subsequent intersections are displayed at unique time intervals, the track history develops. Multiple jamming targets are tracked as raid mass or cell. When the track has been established, the heading of the raid has been established. So has the georef position. By measuring the distance between fixed positions at unique time intervals, an approximate raid speed is obtained. It is possible to estimate raid altitude using strobe data. In general, the farthest site receiving the jamming signal establishes the minimum altitude. The closest site not receiving the jamming signal establishes the maximum. Assuming the line of sight criterion is valid, the jamming source must exist within this altitude interval. Alternatively, MANTRAC equipment can be attached to a height finder for vertical triangulation. This will obtain more precise data on raid altitude if required. The field strength receiver is attached to the height finder and the data displayed on the range height indicator. One problem inherent in triangulation is that of extraneous strobe intersections, or ghosts. Here is a flight path of 2 raid cells passing within range of 3 radar sites, A, B, and C. Now let's go back and watch these raid cell tracks develop. Cell 1 has been picked up by sites A and B. Cell 2 by site C. Now site C has picked up cell 1, and the intersection prescribes the minimum cell outline. As the raid cells progress, the situation is similar except for false intersections. Logically, this intersection could be a raid. At this point, it will be carried as a possible cell location. Cell 1 has maintained a relatively stable course. All 3 sites continue to carry the track. Now, Site B has picked up raid cell 2, and for the first time, there is a double sighting. Now there are 3 false intersections. At time 6, all previous ghosts are gone, and new ones have appeared. As we move to time 7, the consistency of the real tracks becomes apparent. The random intersections tracked only as long as they contain a certain amount of logic. Considering that jamming raids first appear at the nominal radar horizon, that jammers will be detected by different sites at different times, and that ghosts are erratic and inconsistent, it is possible for an experienced operator to infer from the order in which the new strobes appear which intersections are extraneous and which are actual jammer locations. Enemy bombing forces, employing electronic countermeasures. Attack is imminent. The operators have taken their position at the MANTRAC triangulation board. Each corner plotter makes contact with his associated site to make sure that all lines are clear and that all equipment is working properly. The trackers stand ready. The tracking assistant prepares to give the starting command. He times the command to the second, flips the switch, and when the green light goes on, The plotters simultaneously request data. Delay time, 30 seconds. Since the requests for data are simultaneous, all information being plotted is for the same time period. When all the data is in and on the board, the panels are shifted. The shifting of the panels superimposes the data from all sides onto the map on the center of the panel. The interpreter works with this superimposed data. In order to see a particular track history, we'll pick up the raid after it has been in progress for several minutes.
Two along this single strobe picked out by the two there. Bring this top one down. And
the interpreter makes decisions as to true intersections and outlines raid cells. He marks these intersections and cells in grease pencil. He is in constant communication with the trackers on the opposite side of the board. When the trackers have duplicated the interpreter's decision, he erases and prepares for new data.
Now check. 2, 4, 6. 2, 4, 6. 2, 4, 6.
The tracker uses the interpreter's decisions to initiate and maintain the track history. He resolves the raid cell information by successive raid cell intersections. He also transmits raid locations to the Combat Operations Center. The heading of the raid, estimated velocity, approximate altitude, and minimum raid count have all been determined. MANTRAC data is adequate to allow squadron operations centers to make full use of our present weapon systems. Nike, Beaumark with its search while go capability, and the pattern patrol tactic which permits effective defense with coarse raid data. Manned interceptors must know where to go and what to expect. They already know what to do. Even though triangulation is a promising solution to radar inadequacies, there is no triangulation system in operation at present. Using existing prime radar sites and planned position indicators, MANTRAC obtains and utilizes triangulation data. MANTRAC has successfully triangulated on B-29s, B-47s, and B-52s, all of which were jamming. The board grew into a method. The method, aside from accomplishing the desired war game ends, has shown a tactical potential. MANTRAC can use data from a number of sources. It is compatible with Beaumark SAGE, adaptable to SAGE Mode 4 and base control, usable in NATO applications, fleet air defense, aircraft early warning and control installations. MANTRAC is simple. It uses standard components. It is quick, easy to install. MANTRAC is inexpensive. It is effective against spot jamming, swept jamming, barrage jamming, single and multiple targets. In war, you must make the price of admission too high. It doesn't matter if the system is complex or simple. What does matter is that you have a working system at your command.